Hey y'all, Miss Harper here to go over our adding and subtracting polynomials, okay? Poly, if you know what that means, this stands for many, and nomial somehow or another means terms, I think. Don't quote me, but that's what we're going to roll with. All right, so let's look at these. A polynomial is a monomial or sum of monomials, okay? So again, we're talking about different groups of terms. We use these things all the time. So let's first dive in and talk about monomials, okay? Well, if you know what mono means or what that word, I don't know, prefix means, y'all know me, math teacher, not an English teacher. Anyways, this means one term. Okay, one term. Now, one term could look very different. So examples of that, like look right here. This is one chunk of a thing. This is, I have negative 3 x to the 8th power times y's. Okay, I have negative 3 of those. Here, another one term is a negative 9. Or here, 14 m's. So you'll hear a lot. Remember, we've talked a lot about the beginning of the year, like apples and oranges. Different things. So these three are all three different terms, but they are representing one singular term. All right, binomial, think about bicycle. That means two terms. All right, so again, like something like this, we're very used to seeing 4x minus 7. I have 4 x's and then I have a negative 7. All right, 2x plus 9y. Again, two separate terms. They are separated by an addition sign or a subtraction sign. All right, 2 plus 13x. All of these are representing two different terms, apples and oranges. Okay. All right, and then trinomial. Can you guess what it is? Tri means three terms. Okay, and then anything beyond a trinomial we just call polynomial. All right, many terms, anything more than three. So three terms, again, you can see all three of these things are different. We have some apples here, bananas here, and some cherries there. They're all three different things, so I can't combine them technically and call them, I can't add all these things together and say, oh, I have 7 ABCs. Like, that's not how that works, okay? I have an x squared, an x, and then a regular Joe. Okay, I have some x squareds, an xy, and a y squared. Those are all three separate terms. Okay. So let's talk about finding the sum or difference. This is actually really easy. Key thing here is combine like terms, okay? Combine like terms. All right, so again, you're going to hear me talking about apples and apples, oranges and oranges, okay? So whenever we're adding things, now again, you could think of this like a positive 1 here and distributing a positive 1. But if you distribute a positive 1 to anything, it's not going to change the value or change the sign of anything. So officially, these things can actually hop out of the parentheses and we're still good. After I've taken them out of the parentheses, I'm just going to combine like terms. All right, so first I might maybe box my x's, all right, including the value of their sign, positive or negative, okay? So how many total x's do I have here? Well, I have 7 x's, all right? And then look at our regular Joes, things of the same nature. I have a negative 5 and I have a positive 6. Well, 6 minus 5, that's positive 1. All right, a true mathematician. Now, remember, you could also put 1 plus 7x, and those two things are equivalent. All right, I still have a positive 1, and I still have a positive 7x. However, if a true mathematician will always list their variables first in alphabetical order and in order of the degree power. Now, if you don't officially do that, that's okay. But if you want to be totally accurate, that's the move you're going to want to make. All right, so let's look here at number 2. Now, this one is a difference. We're subtracting it, saying this minus this. So now with this minus sign, okay, you need to distribute the negative, okay? And again, you think of that like a negative 1. Okay, so all it's going to do is reverse the signs. So I have this x squared plus y squared minus 4x squared minus 3y squared. Watch out for double negatives. All right, and then again, combining things of the same nature. Here I have an x squared and I have negative 4x squared here. So 1x squared minus 4x squared. Now I have a total of negative 3x squareds. Okay. And again, alphabetical order. We'll talk about our y's next. I have some y squareds. All right, how many total y squareds do I have? Well, I have 1 y squared here. I have negative 3 y squareds here. So 1 minus 3, I have a total of negative 2 y squareds. Okay? And that's how it's done, y'all. So I want you to pause the note video, and I want you to try out number 3 and 4, okay? Try it out, pause the note video, and then you can resume the note video to see if you got your answers correct. All right, so if you're hopping back on here, I just went ahead and pulled everything out of the parentheses because it was a positive sign, so I didn't technically need to distribute anything. Now I'm going to go through and combine like terms. So here's an x squared, and here's an x squared. All right, and those are the only x squareds that I have. Well, what is 3x squared minus 3x squared? Well, that's 0, so those things actually just cancel each other out. Remember, if you were to just write x squared thinking that that was appropriate, well, that's actually representing 1x squared, which is inaccurate. Okay, so make sure that you're just not putting anything, because 0 times any value, 0 times x squared will just be 0, so it just eliminates, okay? Looking at our next term, let's start with these guys. Here I have negative 5 xy squareds, and here I have negative 5 xy squareds. So again, think of that like I have negative 5 apples here, I have negative 5 apples here. How many total apples do we have? Well, I have a total of negative 10 xy squareds. Okay? And then the last thing that I have are these. All right, I have a positive y to the third power and a negative y to the third power. That's 1 minus 1. Well, 1 minus 1, again, is 0. And I hope I didn't miss anything there, but I think that's it. All right, so again, those two things would cancel each other out, and this is all that we're left with. Pretty fun. I wonder if you got that one right. High five yourself if you did. All right, and again, here on number 4, I'm going to distribute real quick. I have the 6x to the third plus 12x plus 4x squared minus 2x squared plus 8 minus 2x to the third power. Again, I had to distribute that negative and change my signs. Now I can go through and combine like terms. I have an x to the third here, x to the third here. 6x to the thirds minus 2x to the thirds. I have a total of 4x to the third. All right, after that I have some x squareds and some more x squareds. So I have 4x squareds minus 2x squareds. So I have a total of positive 2x squareds. All right, and then I'm going to look, oh, these little x's, they're all alone. All right, so positive 12x, he has nothing to combine with. And then lastly, this little 8 guy, he doesn't have anybody to combine with either, and so that would be our final answer there. Again, high five yourself if you got that correct. Now remember, you can have these things in different orders, so if you have these in different orders but they still have the same sign value, as in they're positive or they're negative as they should be, then you are on the right track. All right, shimmying down a little further. Whoa, that was too far. All right, here we go. Some of the measures of the polygons are given. P represents the measure of the perimeter. Write an expression to find to find the measure of the other side or sides. Then find the missing sides. Okay, so remember perimeter. Perimeter means the distance around a figure. So ultimately what it means is add all sides. All right, so let's look at this first one. So what is the perimeter? This question is asking us what is the perimeter. So we do the same thing. Now if you want to list these all out and say 5y plus x plus 2x minus 3y plus x plus 2y, you are welcome to do that. For me, I'm just going to kind of ring around the rosy here. I'm going to add my x's first. Oops. X. So I have 2. 1, that's 3 x's plus 1 more x, that's 4 total x's. So perimeter is equaling 4 x's. All right, and then I'm going to go take a look at my y's. 5, 6, 7. 7 minus 3 is going to give me a positive 4 y's. Okay, and that is the perimeter of that figure. All right, the next one's really fun. Now this one, it gave us the perimeter of this rectangle. All right, there's lots of different ways to approach a problem like this. All right, so first of all, it gave me one side length, which means I also know this side length. So what you could do is you could take what you have, add it together, and then subtract it. So for example, if I gave you like a little minor example here, I said this is 2, and the total perimeter is 10. What is this missing side? Well, and this missing side, well, let's see, I already have 4. That means I have 6 left over, and I would need to split it up, so that means this would be 3 and 3. So what I did was I had 4, and then I just subtracted. I did my total perimeter minus 4, and I had 6 left over. And then I took that 6 and I split it in half because I had 2 sides to split that in between. So we're going to do the same thing here in this problem. All right, so let's take a look at it. Let's figure out what I already have. Okay, well, let's see, I have 3x squared here, 3x squared here. So I have a total of 6x squared plus 5 plus 5 plus 10. Okay, so that's what I have, and up here is what I need to end up with. All right, so you have options. You could take your perimeter and subtract what you have and then split it into 2, or let's just pause and think. All right, I have 6x squared. I need 14x squared, so how many x squareds do I need? Well, I need 8x squareds, and I have 2 sides to split that between. So what do I need to do? Well, I'm going to split that 8x squared. So let's say I need 8x squared. So I'm going to give this one 4x squared, and that means that this guy is also going to get 4x squared. All right, then my x's. Well, look, I don't have any plain old Jane x values, but I need 10x. So I need 10 x's. So that means I'm going to give this one 5x, and this one's going to get 5x. Again, just splitting that in half. All right, and then again, looking here, I have 10, but I need 12. That means I am missing 2, so each one of those guys is going to get 1. So what is the missing side? Well, the missing side is a 4x squared plus 5x plus 1. And again, there's lots of different ways to do that. I'm going to show y'all one more way of doing it. Okay, I knew what I had, so kind of similar to what I showed y'all up there. I know that I have 14x squared plus 10x plus 12, or that's what I needed to get my total perimeter, and I already had 6x squared plus 10. That was adding up the 2 sides that I have. So we can do the same thing here. Distribute and combine like terms. Minus 6x squared minus 10. All right, so let's see, combining like terms, I need 8x squared. I just have this 10x by himself. And then 12 minus 10 is a positive 2. So again, this is what I still needed left over. And then we would just take that and split everything in half because we had 2 sides to split it into. So half of 8 is 4. Half of 10 is 5, and half of 2 is 1. So that's one other way to get to the answer. So whichever way makes most sense to you, take it and roll with it. All right, guys, you're done here with your notes. Go ahead and grab your practice sheet from Miss Harper and get after it. Good luck.